Right. Yeah. Remember, the area model gives you your factors just right here, and then Malia said it, zero product property. Remember, once you set this equal to 0, the factors have to equal 0. And then when x minus 7 equals 0, x has to equal 7. And same thing here, x has to equal -3. So that's the area model approach. Once again, obviously we're going to practice using all of them in a second. But obviously with this one, when we did this on Thursday, we were concerned with using symmetry or the quadratic formula. I was going to use the quadratic formula for the third one, but for this one I wanted to use symmetry. So what was the first step we had to use in order to use the property of symmetry?
Can I pause one thing just really quickly on this area model? Guys, don't forget, if we're using the area model, the whole point Mr. Anderson already talked about is to rewrite it in what form? Factor form. But there's a major problem up here, not down here as much, but up here. What's the whole point of factored form? To use the what?
Zero product property.
The which property?
Zero product.
The zero product property. Hey guys, what's missing up there? Guys, you cannot use a zero product property unless that factored form is equal to 0. Now, was it a function originally?
Yeah. It was.
So why were we able to, because it originally was equals f of x. Why were we able to rewrite that as equals 0? But why is f of x equals 0? Like, what in that problem tells you that f of x is equal to 0? You need to be able to recognize this. Because there's some time, because like it's not equal to 0 to start.
Right.
You have to recognize to set equal to 0. And it's not just that you magically do it. That's right, we're looking for x-intercepts. And what do we know about every x-intercept that's ever existed? The output is 0, the y is 0. Remember, that's also a reason we call x-intercepts what other term? It's something we saw in the calculator when we did it graphically.
First letter.
A z. Oh yeah, we also call x-intercepts zeros because the output is 0. Okay. They're slightly different, but they're essentially the same. Just be careful about that, guys. The whole point is we're trying to find zeros. It doesn't work if it's not equal to 0.
Right. And we did the same thing even when we, remember the quick notes that we took on the quadratic formula, we said that the first step was we have to set it equal to 0. We can't find zeros unless the output equals 0, which we have to set ourselves. So that's pretty much, that's the first step for everything. So obviously I can say that this equals 0 here. But then, what did we need in order to use symmetry to find our zeros? What else do we need? Well, using symmetry is different from there. Remember, didn't you guys do this for that one? What did you do first? Up there. Well, yeah, what you have up there even for number 3, because you all did this approach, right? What was your first step? Right, we need to find h first. We need the x-coordinate of our vertex. That way we know what distance, or where we need to move from, right? So who can tell me how to find h again? Opposite of b over 2a. So when I plug these in, I get opposite of -4 divided by 2 times 1. So h would equal 2. Right? And now does anyone remember what we do next from here using symmetry, thinking back to that other task sheet and what we did on Thursday? Does anyone have that formula?
What does the worksheet look like?
So what do you say again, Walter? So the square root on top? And then what do I put next to the h squared? I think you have it. Yeah.
Ain't the opposite of the outside?
Well, this is just the symmetry model. So we're not using the quadratic formula here. Remember, we're using that other method. Very similar to the quadratic formula, but it's a little different.
Would you like me to turn the screen on so that it's just easier to see?
Sure.
I mean, we don't have to. Would it be easier for y'all to see if I turned the screen on? You like this?
Yeah. Miss, can I have a question?
Walter,
Better than that?
No, keep
We're
it like
going to
this.
say goes next.
Like that over there.
There you go.
Miss Kenny, didn't we have to do it like delta math assignment?
Yes, there is a Delta Math assignment due later this week.
I got an actual question too. They want to
You
use
said it
that's
was
a problem.
Friday.
Huh?
You said, I thought it was Friday.
This past Friday, or is it coming Friday? I think I said I was going to make it due Wednesday or Thursday because we have a test in here on Friday.
Yeah,
Oh,
got
you
it,
got
got it.
Alright, so Walter just helped me write this down. Remember, you guys still have this on that task sheet. It was on number 3 on that 7.8. Gave us this distance formula. So now I can just plug everything in. If I have, we just found h, right? So 2 squared minus, c was, what was c again?
What number is this?
This is the first one.
Negative 21.
Negative 21 and a was, a was 1, right? So then this would give me,
What form are we doing this in?
what do you say, Vinny?
Symmetry.
Never mind.
Plus, well remember, what does this do?
That's it, we can do.
So the square root of 25 is 5. And what do I do with this 5? So I have my h, and I have my distance, right? And what's my last step here?
Divide.
Well, the distance, what does this distance represent, Vinny?
Hold on. I remember doing this. Okay, this distance represents the vertex.
Well, the vertex is this, but remember, where are our zeros relative to our vertex?
On horizontal. On
The horizontal, right? And what was the distance? How do we know how far to go?
We got to subtract on each side.
By,
5.
there we go. So if h is 2, if I'm going to subtract first, what would one of my solutions be?
3. Negative 3.
Negative 3, and what would the other one be on the other side?
Positive 3. Well, 7.
7, right? For everyone who used the quadratic formula, y'all got this too, right? Remember, we can use any of our solutions, we should get the same answers. And these are equal to our x values. And if we want our specific x-intercepts, remember if we want them as points, the x is the negative 3, and then what was our output again?
Wait.
Our output is always 0, right? So that's, once again, how to use the symmetry model and using the distance from the axis of symmetry to add and subtract from our vertex to get those. Now, oh, I don't have the sheet. Mr. Kenny, do you have the original problem for the third one? So I know some of y'all didn't get
2x
to...
squared,
D.
2x squared plus 5x plus 1?
Mr. Anderson,
We can,
Yes.
on the h, well, what we calculated to get h. Is that a positive 4 in parentheses?
Here it's a negative, but remember it's opposite of b, right? So b is negative 4, and then we take the opposite of it. Remember, when we figure out a, b, and c in standard form, the signs always follow. So because it's minus 4x, the b is minus 4. But then it's opposite of b, so we made it positive. And then, wait, sorry, say that again, Mr. King.
2x squared
Yeah.
plus 5x plus 1?
And we're going to make this equal to 0. So that key first step is already here for us, right? It equals 0, so we know we're finding x-intercepts. So now for this one, I know some of y'all didn't get to it, but I do want to use the quadratic formula for this one to get practice, so we can do the symmetry and we can do the quadratic formula. So does anyone remember just what the quadratic formula is? Does someone have it down?
Negative b plus minus
Yeah.
radical
Yeah.
b, opposite of b, square, parentheses over. Minus 4 times 8 and t.
4AC all over 2A.
Perfect. Remember, Finney, inside, although it doesn't really change because when you square it, it's going to become positive anyway. Inside the radical, it is not opposite. It's just b squared, although it wouldn't change things. So now who can help me fill in this based on what we have here? Well, using the numbers that we have.
Fill it in, okay, negative b. So negative 4.
Just know it's minus 5
Yeah.
What do we get that from? Okay.
plus or
We
minus
doing the second one.
square root
Mm-hmm.
5 minus 4 1 and 2 divided by 2. 8.
2 times,
8.
which is?
2.
2. And what am I missing here? Exponent on?
No.
What?
Which one? In the radical, right? Remember, this has to be squared. And then, yeah, everything else is filled in based on A, B, and C. So now I'm just gonna combine everything inside. Remember, we could just plug in, we're gonna be working with specifically what's inside the radical is what we're gonna be focusing on today on our first task. So what I wanna do first is simplify everything that's inside here. So we could just plug this straight into the calculator. So 25 minus 4 times 2 times 1 is 8. And then we can plug this all in the calculator and find out what that radical is. Remember, this is going to be divided by 4. So then this gives me negative 5 plus or minus the square root of, does anyone know what this is inside?
17.
17 divided by. Can we simplify what this square root of 17 is?
No.
No, we don't know what that is, right? So I'm going to leave my answer just like this. And then these are equal to, remember, what do these numbers represent? We found our, what were we solving for? X intercept.
Half of the class.
What you said?
We feel like you're teaching half of the class.
Walk.
And nobody on this side understand what you're talking about.
What is going on?
And I can't even,
Next question is.
I can't even see what you're doing.
Okay, move your seat.
Bro, I've been. Don't make me act a fool now.
Do you have a specific question with
No.
that? You guys in the back? I will try to engage with this side.
What?
Leave me alone, John.
Bro, I ain't gonna lie, Corey.
I ain't gonna lie, you should have talked to me.
What you just said, so you know.
Okay.
So just cause.
Alright, does anyone have any questions with using the quadratic formula?
I didn't ask. Stay in your lane. Each of
Why
you.
you telling me that? I ain't gonna do
I'm saying both of you.
Yeah.
I didn't ask. You are responsible for you, Ivan. You're not responsible
Is
for
that
her.
a schoolwork?
You sound like my dad, Mr. King.
Where?
You sound like my dad.
This is a 2
I'm already
here,
gonna be there.
and here as well.
Then you got like, you got 2 problems, or you gonna break one of them, done with.
Which one? Well, this green, this is the problem for number 3, anything on the bottom. This top is the first one.
Oh, no. I know. Leave me alone, John. You guys-
Can you restate the question, Mr. Anderson?
Oh, I was just wondering if anyone had any questions before we move on to the next slide.
I actually do have a question.
Yes.
Where do we get negative 5 plus or minus 25 minus 8?
Bro, the thing is,
I'm simplifying what's inside. So I just moved this into here because 5 squared is 25, and then that multiplication gave me that part.
Wait.
Where do we get 17 from?
What?
Where do we get 17 from?
5 squared.
What's 25 minus 8?
Benny, you also have calculators. Please use them to do calculations. Like you could have just typed in 5 squared minus 4 times 2 times 1.
I got you. Okay. It's all love.
Alrighty.
Ready?
Yeah. Alright, so we're gonna take like a couple minutes just in your groups. We got, oh, well, here's our agenda for. So we have 2 tasks that we're going to be working through a little bit today. There's one specifically with imaginary numbers, and then there's one with solving more, using the quadratic formula again and working with that square root. And then at the end, well, at the beginning, we're also going to be looking at different equations and trying to find how we're going to solve them. And if we get to it at the end of class, we have another sorting task of trying to figure out what the most efficient way of solving quadratics is, based on what the form is and what they look like. There is a DYU tomorrow. There's going to be all our methods on it, including, right, the quadratic formula, Mr. Kenny? I believe is on it. Mr. Kenny, quadratic formula is going to be on the DYU tomorrow?
Yes, and the distance.
And the distance thing. So that square root of h squared minus c over a that we just did is also going to be on it tomorrow, so please study that and remember that as well. We're going to practice that too. But Walter? The quadratic formula, yeah, that is on it too. Still working with everything that's in here. and this stuff too. We're mainly gonna be looking at this specifically, like recognizing the differences between the forms and what that represents when we're looking at solving our equations. And obviously this is still kind of new, but we're gonna be practicing with that more as well. So this is what I was gonna start with, just if we could take like 1 or 2 minutes just in your groups and try to figure out how, don't solve it yet, but we're gonna figure out how we're gonna want to approach solving these, yeah, for the first one, the second one, and the third one. So take like 2 minutes and just come up, see what you can come up with for how we're gonna solve each one. Like which method you're gonna use. We're not solving it, but just tell me which method you want to use to solve it.
Well, I know that, I just like, all those people. Why'd you switch your cord?
No.
I had a
Why you
queen.
gonna act like that?
Ooh, you better look at this camera.
I'm tired.
I need it from you, and why are you trying to
Hey guys, just a heads up. Hey, really quickly, just because I want y'all to be aware. Yeah, so we have new erasers. Use those. 2, we finally got our school money, so I got some more expos. But we still should not have more than 1 expo per group. So if your expo starts to die, throw it in the trash over here, and the expos are right behind the camera. Please remember what's the only color you do not grab? Purple. There we go. You got plenty of expos. Don't grab purple. I'll fight you. That one's good. Thank you. Yeah, that's what we use to keep talking. Walter, put the Delta math away. Work on this problem.
What do you want? What do you want?
Which one of these is this?
You ain't want shit.
Alright, what is your strategy that y'all came up with?
I'm still kidding.
So what's the strategy you came up with?
I'm still kidding. The camera's on. I don't care.
So why are you trying to put stuff over? If it's a standard form, it's using the quadratic. However, I guess
And I'm gonna tell you since you're saying I've been waiting. Mr. Anderson, I can't see it.
sorry.
Somebody say that.
Wait, do you
No,
somebody say that?
I'm talking about you. We talking about you, baby.
Alright, so
I ain't talking about, I don't talk to you. Oh, just shut up.
yeah.
That's my homework. I'm not talking about me.
Yes.
I don't want to check that. I don't talk to you. He not serious. He not no group, but he do pull, like he pulls, he like. No, I'm saying, but he pull with everybody. But he pull with kids too.
You switch your cord out, well, you switch your
I had a queen.
How are you?
It's that thing. No, they're gay.
So you switch your cord out? You switch your cord out? You switch your cord out?
He had a king, I was over the
You had a queen.
You had a king.
Yes, for sure, yes, sir.
He had him.
He don't want you to talk to
Remember
me.
that first.
He just wants to race me. How you messing up my booty?
Abby, don't solve, man.
There's differences.
They just gave me a queen. I'll be right back.
No, not yet.
D-Bro, oh my God.
You were just solving it. You were just solving it.
Stop.
Okay, do the big one. Erase it. Erase it.
Mr. Anderson.
Yes. Maybe also have
Today right now.
Yeah, I'm about to go over it.
And
Alright, hopefully y'all had enough time to come up with some strategies. We're gonna work together to solve in a second. But, so can someone tell me what they wanted to do for f of x here?
You can do factor or you can do distributing.
Well, do we have to distribute?
Yes.
Why?
Because
Remember what, okay, so what form is this?
factor.
Okay, what have we used when we see factored form?
Distributing.
Have we distributed?
No, sir.
What property have we used?
Zero product property.
Can we do that instead? Is that easier than distributing?
Zero product property.
How do I do the zero product property?
Equals zero. Oh,
Hey,
now
guys,
you
I do want to point out, because Brianna is erasing it, what does distributing allow us, or get us to?
zero.
Distributing gets us to the standard form. Hey, what's the only form of a quadratic you cannot solve in?
Standard.
Okay, I know, and this is why we have to think through strategies. I know that we're used to distributing, but you need to think through what will distributing do for me. Distributing's only gonna give me the standard form, and that's the one form I don't wanna use.
Yeah.
Okay? Slow down and think through what's the end goal. Don't just do a thing. Why are you doing it? You've got to think through the why.
Remember, we should recognize as soon as we see factors, obviously factored form, zero product property. Because we have a product of two factors, so then now how do I use the zero product property?
What's going on with this? What's going on with
Do what?
this clock? What would it be?
Was the -2, well, that would be distributing. We don't want to distribute. If I move the -2 in here, isn't that multiplying, isn't that distributing? So I want to leave that -2 alone. Remember, is this -2 going to change our answer?
No.
No, because when I multiply it through, we want these factors to be 0. What happens when I multiply 2 on the outside by 0?
Zero.
It's just 0 anyway, right? That 2 doesn't affect, or well, negative, but that -2 isn't going to affect our answer, so we could just leave it alone. So what do I do with our factors? So I set the factors equal to 0, right? So if the first one's x minus 3, what would x be equal to? Right, so if I add 3 to both sides, I would get x equals positive 3. And what about the second one? Minus 1, right? If I have x plus 1 equals 0, and I subtract 1, I get x equals -1. I mean, I think that doing zero product property is the easiest way of doing it. Obviously, we can't do it unless we have factored form. Obviously, if we're given standard form, what can I do to convert to factored form if I wanted to use the zero product property? I could use the area model, right? But there is probably an easier way if we don't want to convert, but we'll get to that in a second. True. So what about for h? What do we do? What do we think to do for h of x?
Vertex.
So what do we know about the vertex? Well, what form are we in? We're in vertex form, right? But what is the solution method once we have vertex form? What are you saying? Well, it's not really distributing. Well, so what's my first step again? I got to set it. Right. So what do I have to do first? Same thing I did here. So I got to set it equal to 0 first. And then remember, this is called, we say we're using inverted to get x by itself. So the first step is still always setting it equal to 0. That way we know what we have to do for our inverses. So what's the first step in our inverses? What do we have to do first? What are you saying, Wayne? Right, we have to get rid of everything on the left side that isn't x. So the first thing we have to get on the other side is 8. So we subtract it from here, and we subtract it from there. All right, what's the next step? Divide by. Right?
Positive 4.
Okay. Alright, how do I get rid of the square root? Or how do I get rid of the square? I take the square root, right? So then what do I get on this side? Exactly. So we're going to have a positive, and we're going to get a negative 2. Alright, so then how do I get my answers from here?
Oh, plus one.
So x could equal
3.
3,
Or then 1.
or it could equal,
I mean negative.
yeah, no, you said it right.
Oh, yeah, negative.
Or it could equal -1, right? So remember, we should be able to recognize if we see vertex form, we can just start by doing our inverses right away. Because we only have one x to worry about, that's in here, and then we can just get everything on the other side by using our inverses. Remember, we're creating those identities on this side, our zeros and our ones, and then we end up with our answer. Alright, now what happens if we have standard form? Can we use the zero product property?
No.
Can we use inverses?
Quadratic formula.
So we could use the quadratic formula, right? Because what do we have, what does standard form give us that we need for the quadratic formula? What do we need for the quadratic formula? Is h in our quadratic formula? A, B, and C, right? If we have standard form, we have A, we have B, and we have C, right? So once we find those letters, we can just substitute them into the quadratic formula. A, B, and C is easier?
Like, why do we use A, B, and C as the
Specific,
coefficients?
Well, they don't want to use Z and X because sometimes those are used as variables.
X, Y, and Z are the most common variables that we have. A, B, and C starts at the other side of the alphabet.
Yeah.
And it allows you to go, if you go A, B, C, etc., that allows you to get up to 26 coefficients. Really kind of a few less. But that's the big reason there. It's possible to go even beyond that, which is when we start using a sub n, a sub n minus 1, etc. But it just means the nth coefficient. But don't sweat it. Not quite the same. You ready for? No, you already talked through the last one.
I could go through the quadratic formula, but substituting, but
No, wait. Oh yeah, you already talked through the details.
So remember, standard form, we can just substitute right in the quadratic formula. These are the three most efficient ways of solving based on our forms. So the most important thing here is we have to be able to recognize what form we're using. That way we can identify those solution methods once we have the form.
And not distribute when it's factor
Yes,
form.
please do not convert to standard form.
That for your sake, I will point this out actually. Could you convert to standard form and then solve? Yes. Is it going to make your life harder?
Yes.
Yes. That's why we don't want you to do it. It's for your sake. Please don't do it.
Because remember, I mean, if we have this form, we have this way of doing it, which we could just do in one step once we have this. But if we convert to standard form, what are we still going to have to use after we do that? Well, we're going to have to use the quadratic formula, right? So if we can just jump to solving from here, we don't need to add that extra step of converting and then using the quadratic formula. And the quadratic formula is kind of long and tedious anyway. Meanwhile, for this, all I have to do is say, okay, what is x minus 3? When is x minus 3 equal to 0? It's easier to find that than plugging everything, substituting into the quadratic formula. At least in my opinion. Alright.
It's right.
Sweet. So this is,
Just a quick.
yeah, this is, remember that task that I did with you guys on Thursday. So we're still working with this idea, right? So we found this square root of h squared minus c over a. Does anyone remember or have still their answer from Thursday what this value represented when we computed that?
-4.
What type of distance? It was a distance, right?
3.8.
It was a horizontal distance, right? And what did that where did we use that horizontal distance to find? So we used it, we calculated it from the vertex, right? Or we could also say from the line of symmetry, right? And then what did that give us when we found this? We used that distance outside of the vertex, or we added it to the vertex. What did that give us? The x for the...
Wow.
What did we have once we took this distance? So we have, remember, h, our vertex. And what did we do with this distance? well, we do at the end, right? We have the square root. But once we find what the distance is, what did we do with it compared to h? So we took h, we added and subtracted it, right? And then what did these values give us? I'll say d for distance. And then what did those two numbers give us? It gave us the zeros, right? The x coordinates for our zeros. Because they're the same distance away. If I have my graph, for example, like this, or, yeah, let's do this. Remember, these zeros should be the same distance away from our vertex or our line of symmetry. So this is plus d, obviously, on the right side, and then minus d on that left side. Right? Alright, so now we're going to be working more with this and the quadratic formula. We did those quick notes, so now we can talk specifically about, we're going to be working a lot towards the end with the imaginary numbers, practicing adding, subtracting, like figuring out what to do once we actually find those imaginary numbers, which is I, of course, and just understanding what is real compared to what is imaginary, and specifically simplifying square roots. That's where those imaginary numbers are going to come in. So,
Really quickly, just to remind me and to help Mr. Anderson, what did we end up talking about with I towards the end of class on Friday?
Inverse.
Not an inverse.
I squared equals -1.
there we go.
Yeah, we find as a number.
So this is how we're going to define I going forward, and I mean just for this task and for the next task, this is important to know, is that I squared is equal to -1. Obviously in the real numbers, we always say that we can't have a number squared that equals a negative, but that's where the imaginary numbers come in, is that we say the imaginary number I, when we square it, we end up with -1. This is I. So, oh, did you hand this out? Do you want me to hand this out?
I can hand it out.
So this is the first task we're going to do. It is called Imaginary Friends. We are going to be using the quadratic formula. So this is just the first one. There's 3 of them on the front. We're going to be using the quadratic formula to find the zeros, and then we're going to try to come up with like a sketch of the graph, and we're going to see what we can figure out about the zeros, or the solutions, based on what we have in the quadratic formula. So Mr. Kenny's handing this out. We're going to be working obviously on our vertical surfaces in groups just to tackle the first parts A, B, and C. For number 1, we'll start to go over them as we work through. But
Baby girl.
Look at the letter.
It's 2 different lessons. The first paper.
the first paper is what this is, right?
If you listened when we just talked, the first paper is the lesson, and the second paper is more for practice.
And if you don't like space ones,
Keep them in order.
which game?
We need some.
Alright, everyone should have the sheet now, so if we can get up and get to work on number 1.
It's about 8
Yes, sir.
plus 2
Alright.
Yes, sir.
Yeah.
Hey, Mr. Anderson,
Yes, sir.
we're just working on this page today.
That first, yeah, no, the only the mathematics one for now. So it's, I think it's just the 1 page. Oh, well, we're doing those a little later, after we finish with that. So keep those out for a second.
So it's a package. I don't know why. I don't know why they did it. Hey guys, I need y'all up and at a board.